Hi, I'm Randall Heyman. I have over 150 Corona help videos, so if you'd like me to make a video for you, comment below any of my videos or drop me an email. So this is for Balthazar. It's the third one I've made for him. We're clocking through the isomorphism theorems for groups, so we're up to the third one. So let's read through it. Let H and K be normal subgroups of a group G, with K a subgroup of H. So let me pause there and make a few comments. What you should have in your mind at this point is here's G. Within G we have H, and within H we have K. The other thing I'll point out is this word here, normal. There's a pattern between the isomorphism theorems. The first isomorphism theorem has no mention of the word normal. There is actually a normal subgroup in there, but you won't normally find normal in the statement of the theorem. The second one will always have the word normal for one subgroup, and the third one will have normal for two subgroups. So there's a little bit of a pattern there that might help you remember. Now let's go to the killer line, which is if everything's satisfied with all the normal subgroups that we just talked about. Then if we look here, we can see that G quotiented out by H is isomorphic to this monstrosity on the right, which is G quotiented out by K, which in turn then that whole thing is quotiented out by H quotiented out by K. Just in terms of memorizing, you can see if you're in high school with fractions, you would say the K's cancel out. Obviously, this is a completely different process, but just in terms of remembering, that might help you. Okay, so how can we visualize this? Where's my little, I'm going to draw a diagram. Oh, I must have put it away, my template. Okay, I'll just draw it this way. Let's go black. Essentially, we want to go like that, and like that, and then we'll try and join these up. There, there, and there. Whoops, that'll do. Patch that up. Okay, let's draw some arrows. This won't completely, this helps. I think it helps. G, we've got some alpha homomorphism, which maps G to G quotient out H. We can also go the long way around. So we can go G quotient out by K, and then gamma will take G quotient K, and then quotient that out by H quotient K. And what the theorem is saying is that this line here represents an isomorphism. So this is isomorphic to this. I think it will become a bit clearer when we do an example. So let's let G equal the integers with the operation addition. From now on, I'm going to assume everything uses the operation of addition. Now the next one down was H. Within G we had H, and so that'll be 2Z. And within H we had K, which will be 6Z. Okay, good. So now we start clocking through this in terms of a real example. So G quotient H. So what is G? G is Z. What's H? 2Z. Okay, so the best way for this theorem to think about it is what are the cosets or equivalence classes? The cosets are, we could express them as, let's call it I plus 2Z, where I is equal to 0 and 1. So there are two cosets with I equals 0, I equals 1. Okay, now let's do G quotient out by K, which is going to be similar in some ways because it's just Z quotient out by 6Z. So what are the cosets here? The cosets are J plus 6Z. And here J is equal to 0, 1, 2, 3, 4, 5. So that's our 6 cosets. The next thing we're going to need is H quotiented out by K. Sorry, I keep writing vertical lines. They actually should be at an angle like that. HK, so what's H? H is 2Z, and we're quotienting out 6Z. So imagine you're talking to an alien. He understands 6Z, but he doesn't quite get 2Z. So what you would say is, well, you would say, well, 2Z is actually K plus 6Z. So you understand 6Z, Mr. Alien. So you just have to add 0, 2, and 4 onto 6Z, and you'll have 2Z. And then finally, we need to do GK, which we've worked out, and HK. So GK is, so this is Z quotient 6Z and 2Z quotient 6Z. Okay, so cosets are, okay, so we've got an alien who understands this, which is 6Z plus 0, 2, and 4, and we have to explain these cosets. So I suppose what you could do is you could say, well, look, it's K plus 6Z, which you understand, Mr. Alien, plus we'll also add an L, where L will be 0 or 1. Now, yeah, so if you now compare this to this, or if you like this to this, if you compare the cosets, you'll see that you get all the cosets. This one up here, yeah, essentially it gives you the same thing. Or another way to think about this is that this K plus L, essentially all that's giving you is, say, M plus 2Z. Where M equals 0, 1, which is even closer than to, that is then even closer to that. All that happened is I've just changed M to an I. So I think that makes it clear. Yeah, I think that's good. Okay, so any questions, comment below any of my videos or drop me an email.